Hello everyone, welcome to today's video. Today we're going to have a look at the question paper 2 of 2020 November for grade 12 mathematics. So question 8, that's what we'll be looking into, and it consists of circle geometry as well as proportionality theorem. So you'll notice that throughout the question or paper 2, you'll find that from question 8 onwards, you'll see a lot of circle geometry. But the question I've chosen today is sort of an introduction to circle geometry, as well as, getting a brief of how proportionality theorem works. So let's have a look at the question. Question 8.1, it is giving us a statement in there, and we're seeing a diagram of try to roughly draw it here. So please don't mind my scaling. Hopefully you get the gist of what is going on here. So O is the center of the circle, and KOM bisects chord LN. KOM bisects chord LN. I'm going to come back to that. MNO is equal to 26 degrees. MNO, 26 degrees. KP are points on the circle with NKP equals to 32 degrees. Thus, NKP equals to 32 degrees. And then they are saying OP is drawn. There are many things to note when dealing with circle geometry, and one of them, very important one, is to be wide awake. So I usually advise some of the people I tutor that please make sure that when you go to circle geometry, you are sober-minded, no fatigue, and you are still excited about the question paper. It would be a good suggestion that you probably should start with circle geometry while your mood is still up there, while your brain is still at the utmost functionality, because there are many things here to note, and every time you attack a question, you should always be wide awake so that you see certain corners that individuals who are just focused on that specific point might not see. So they are telling us about things here that seem like, no, these things are practical, it's exactly what I see. So they're telling you KOM bisects LN, and you will think, okay, no, this line goes to this line. But up until they've told you that it really does bisect, or you can see on this diagram that this MN is equal to LM in there. That means that we're bisecting. And what does bisecting mean? There's intersect and then there's bisect. You can intersect but probably not bisect. Bisection is a part of intersection, which means that specifically for bisection, we're talking of intersecting a point in that line, but dividing the line equally. So you see that this line comes here and bisects this, so it means it divides it into two parts that are equal. So that's the first thing to note. And then we're also told something like MNO is 26 degrees. I mean, I can see that that's 26 degrees, but is it stated that indeed this angle belongs to MNO? So always make sure in circle geometry you check if something is stated, or you can prove whatever your assumptions are. So if you say these two are equal, can you prove that they are equal if they haven't told you that? So that's the first thing to note. Before we take too much time into that, let's dive into question 8.1.1. We're going to start with A. A is asking us to calculate the angle of O2. This is the angle that we're speaking of, O2. So 8.1.1A. Alright, O2. Like I'm saying, or like I've said at the start of the video, that please be awake when dealing with circle geometry. So when looking at O2, you must look at sort of things that make up that angle. So that is, there's this line here, and then there's this line here. These lines sort of intersect the circle at N and P. And you see that that line is subtended by this sort of part of this circumference of the circle. So a portion of that. So Pn subtends. When we talk of subtend, we look of it as a structure that when looking directly, or when whatever we have as say something that sort of mimics a triangle in here, it is closed. It is closed by this arc here, this arc Pn. So that we call subtending. That it's closing this, and sort of the angle, you can see it as being opposite that arc. Not only is opposite, but we are having it closing whatever sort of is inhibiting that angle. So we have OP, ON, but it is closed by Pn. So it's subtended by that. Another thing, we see that the same is happening for K1, this angle in here. There's Pn common between this OPN and NKP. So there's this arc here which is subtending K1. Alright, why am I mentioning this too? So this angle is at the center, and you might already be thinking, oh, we're probably going to be using the theorem that relates to the center. And you are right, but you need to check which angle is at the center and which one is at the circumference. And the most important thing for that equation is to check if those two angles that you're about to work with, are they subtended by the same chord or arc. And we see that here we have NP subtending both of O2 and K1. So this is an angle at the circumference, this is at the center, and the angle at the center is twice the angle at the circumference. So we can figure out O2 using K1. So O2 is equal to 2 times K1. The reason, angle at center is twice angle at circumference. You're going to write that in full. So what is the answer? So 2 times what we have there, 32, which is 64 degrees. That is our answer. We fill that in here, 64. Hopefully you can see that. We have O2, and now we're looking for O1. We're looking for this guy in here. Where is O1? O1 is at the center. Can we use the angle at the center subtended by the same chord with an angle at the circumference? We see that there is this chord here subtending O1, but there's no other angle that is subtended by the same chord that is at the circumference. Also the arc is, this arc KP is subtending the same angle, but there's no other part that is mostly interesting in that sort of option. So we're already cancelling out that reasoning that we had for question A. What do we have to note then here is that, okay, we've exhausted that one, but what we can notice is that, okay, O1, O2, and O3 are forming, or are on a line, a straight line. And you know that because we're told that the line KOM is bisecting LN. It's a line, and lines are straight. So when we talk of a line, look at it that way. This angle. So if that's the center of the line, or wherever in the line, the angle here is equal to 180 degrees. 180 degrees. The angle also this side, 180 degrees. Those two angles summed together should form 360. Why am I alluding to that? So we already know that O2 plus O3 plus O1, so B, O2 plus O1 plus O3 should be equal to 180, and those are the angles of a straight line. That line I'm saying sum, this is a sum symbol, sum to 180. Angles of a straight line sum up to 180. Alright. So we have O2 here, which we've just calculated, but we don't have O3 and we don't have O1. So there's also an unknown in there. So the question is, can we get O3 easily? That's where you have to look at the bigger picture. O3 is in a triangle in here. And we know that because there's this ON line, that's a radius, it starts from the center to the circumference. And we've also been told that this line, KOM, ends on that line, LN. And also know that this is one line and it's divided. So we have some sort of a triangle in here, which is OMN. In this triangle, what we've seen is that these two lines are equal. Alright. What do we know about a chord that is divided into two equal parts? Because there's a line from the center. You might be thinking, okay, there is a theorem that says that an angle, a line from the center to the chord perpendicular, that sort of cuts the chord perpendicular, will bisect the chord. But what we see here is that the chord is already bisected and we don't have any angle in here. So we can work in reverse to say that, no man, this angle here is definitely 90, this one is definitely 90. Why? So M2 is equal to M1 equals to 90 degrees. Reason? These angles, so this line cuts here and we're seeing that these two are being bisected, which means that since this is a line from the center, definitely cuts that line at a perpendicular angle. So the reason is that line from center bisecting chord is perpendicular to the chord. Alright. So we can figure out what then is O3 because we have a triangle that has M2 and 26 degrees. And how can you figure out the third angle in a triangle? Easy. We have O3 plus that 90 degrees angle, this one. And then we add 26 degrees. So this angle plus this one plus then this one should give us 180. And we know that because this is equal to 180. Angles of a triangle sum up to 180. Please write that in a very well written English. But what I'm aiming for you to get from this question is the intuition, the basics, which you're going to take and project to any question you might see in circuit geometry. So we can figure out from this equation that, so summation of these two, and you take to that side, we're going to have O3 equals to 180 separated by these two in here, which is going to be 116, and this angle is going to be rather be safe. 180 minus 116, that's 64. That's 64 degrees. So we know that this guy is also 64 degrees. Okay, now we go back to this line in here. Now we have O2, we also have O3. Then how do we find O1? So simple also. O1, we take O2, O3 to that side to separate them from 180. So O2 is 64, this one is also 64. What is 64 times 2? It's 128. So O1 is equal to 180 minus 128, which is going to be equal to 52 degrees. That's our answer. O1 is 52 degrees. Now we are going to have a look at the next question. Alright. The next question is asking us to prove that Kn bisects OKP. Okay. They're asking us to prove that. What does bisect mean? It means that whatever we are bisecting or we are cutting, we cut it equally. So what do we define as equal in OKP? If this line cuts it exactly in half, it means this angle here should be equal to K2. These two angles should be equal, but how do we then prove that? So that's a mission that we should first understand the statement, figure out, okay, from the statement, what happens when something is bisected, and then how do I prove that indeed those two are equal? Alright. One thing to note in here, it is a tricky question, but you should go to the skills that you have in cycle geometry, which I hope with this series we're going to capture some. Not all, but each and every day we're going to cover some part into cycle geometry. So we see triangles in here. There's this triangle OKN. So if we can find out this angle, that's our mission. And if we happen to find it equal to this one, then Kn does bisect that. So where does this angle fall into? We see K2 falls into this triangle here, OKN. Okay, and then so it's OKN. Do you see this triangle? And we also see that it's falling in this triangle OKP. All right. What do we see that's there's also another triangle which is KMN. So this big triangle in here, K2 is also in there. So now you have to select your triangles. Which one is mostly beneficial to you? And the first thing you need to consider when selecting the route you want to take, do you have minimal unknowns? So if we look at this triangle, we see that O1, we do have O1, O2, we do have O2, but we don't have this guy, so O and K, we don't have this angle in here. We also don't have this one. But what can we see about that triangle? O or KO is a radius. What is a radius? A radius is simply a line that starts from the center to the circumference. And you see that KO does start from the circumference, from the center to the circumference, but you also see ON. So what we're actually seeing there is a triangle like this. What we actually see is a triangle like this that has this side. So if we look at this as O and N and K, we have this as the radius and this is the radius. So these two are equal. So we start there. Okay, 8.1.2 OK is equal to ON, those radius. Okay, What do you know about such a triangle with two sides being equal and the other one, we're not quite sure, but you can already see that it doesn't start from the center, which means it's bigger than the others. So what's a triangle that has two equal sides? We have an isosceles triangle, we have an equilateral triangle, we have a scaling, the laws of them. But what we see here is that there's two equal sides here, which brings us to the isosceles triangle. And in an isosceles triangle, these two angles are equal. We have A here and B. A is equal to B. And then that other one can be bigger or less. So if it happens that this angle A and B is also equal to this one, then it means that this side is also equal to everything in there, and then this triangle is an equilateral triangle. All sides are equal, but we don't have that at the moment, or we haven't proven that. So we can already tell here that, okay, O and K, angle O and K is equal to K2. So please get familiar with different ways of noting a triangle, like an angle. So O and K, the letter in the middle denotes the actual angle. Because for instance, why do we use this and not just say N, angle N? But what is angle N? Angle N can be this, angle N can be this, angle N can be 26, or angle N can be this. So what are we talking about? So we're talking about, if you have to start from here, jump here in this side. So we are isolating this angle in here, which is O and K. Then we put a cap on top of that. So O and K is equal to K2, because, like we said, it's a radius. So it's angles of isosceles triangle. So it's the adjacent angles. So adjacent, we can add adjacent in there, of a triangle, of an isosceles triangle, are equal. And then what do you do from there? You already know that, okay, K2, then it means we can replace this guy as K2, because it's equal to K2. And this is a complete triangle. So we already know that then O1 plus O2 form this angle in here. There it is. If we were to add it to K2 and add it to O and K, which is literally your K2 again, because we said these two are equal. This should all be equal to 180 degrees. And we know the values of O1 and O2. The other one is 52, other one is 64, plus K2 is 2 K2s. 2 K2 equals to 180. So the reason here is that the angles of a triangle add up to 180. I don't have space. So we can solve K2 from here. So 2K2, we take all of this to that side, but we first have to sum this. What is 64 plus 52? If you can do it by your head, that's good. Rather be safe. 64 plus 52, 116, therefore is 180 minus 116, which is equal to 64. So to find K2, we have to divide by 2 this side and 2 here. So K2 is equal to 32. What do we notice here? This angle is 32. Therefore, Kn bisects OKP, because then you continue there, because K1 is equal to K2. Alright, let's move into the next question. All right, question 8.2. We are given a triangle ABC. Triangle ABC. And also F and G. F and G are points on sides AB and AC. So this line FG is connecting to a point that is along AB and is also connecting to the other point along AC. They have told us that, we didn't assume. Then AB and C, okay, so they connect to AB and C respectively. D is a point on GC, so D is a point on GC such that D1 is equal to B. Alright, that's it. So we go to 8.2.1 in there. The first question is that if AF is a tangent to the circle passing through point FGD, okay, then prove that FG is parallel to BC. So prove that this is parallel to this one. Okay. It's not yet parallel, so let's replace that. Okay, so just try to redraw this. So we have a circle, very bad circle. And in there we have the point D on the circle, we have the point G on the circle, and we have F in the circle. These are connecting like this. Okay. So D, but the angle D1 in here, we have G, and then we have F2 in here. And they're saying there's a line like this. This is a tangent. What is a tangent? A tangent is a line that only touches the circle once. Line that only touches the circle once. So we know that this line here that I badly drew is only touching at this point F. Now they're asking us to prove why, or prove that FG is parallel to BC. Okay, so before I take into this question, we need to just get familiar with how we prove something is parallel, or what do we gain from a parallel, like parallel lines. If this line FG is parallel to BC, it simply means that we have this angle here equals to this angle in here. We'll call that corresponding angles. And also this one equals to this one, it's corresponding angles. So if angles make an F like this part and this one, those are corresponding angles. If we had a Z in here, so if you had to have D exactly at C, these angles here are called alternate angles. Those are the things that you try to look out for, hidden things you look out for when you're trying to solve this line. So we're trying to prove that this line is parallel to this one, but in this case, we're trying to prove that this line is parallel to this one. So let me erase those. Alright. So what do you see that can be of useful nature in here? That if we can prove this guy is this line, then it means we can have that F at AF and then BC. So we can have this angle equal to this one. So the goal is to prove that this angle is indeed equal to that. And then if it is equal, we say FG is parallel to BC. Okay, but what do we know is equal to this angle? It's D1, which we have here. Then we have AF being a tangent, and then we have this chord. We know that this is a chord because I said points A, F, G, and D are on the circle. And then we know that there's a connecting line from F to G. So it then means that these are our chords. This is a chord, this is a chord, this is a chord. And then we have a tangent. Can you recall something? We have a tangent and we have a chord. There's a theorem called tan-chord theorem. A tangent so at the angle subtended by the tangent. So angle at this tangent point here is equal, so it's the angle between a tangent and a chord. Angle between a tangent and a chord is equal to the angle, the opposite interior angle of a triangle that is subtended by the same chord. This is provided that this D is on the circle. If it was a D just floating in here, then this no longer applies if the D was here. But in this case, it's at the circumference. So this is an interior angle. So all these angles are interior angles. This angle here is interior, this is interior, this is interior. But they are saying the angle between the chord and the tangent is equal to the opposite interior angle. Opposite interior angle subtended by the same chord. If you remember from the previous question, I explained that to subtend something is to sort of, we have the enclosure in here, but what fills in that enclosure? So it's going to be that chord, depending on the direction you're looking into. So this FG or GF subtends D1. So we already know that the angle F1, angle F1, this is for 8.2.1, angle F1 is equal to D1. So it's tan chord. Let me wipe this off. So we call this tan chord theorem. Hopefully you'll remember from what I've just explained that an angle between a tangent and a chord is equal to the interior angle that is subtended by the same chord. Alright, so if this guy is equal to this one, but D1 is equal to B, therefore F1, because if this is equal to this, but also this is equal to this, then it means this guy is equal to that one. Easy, right? So F1 is equal to B, and then if these guys are then equal, we know we have a corresponding angle in there, it resembles that F. Therefore, it means FG is parallel to BC. And what is the reason for that? Is then we have corresponding angles. Corresponding angles. Angles F1 plus F plus B. So it's F1 and B. Okay? Now we're going to move into the next question. Alright, next question. We are told that AF, so AF over FB is equal to 2 over 5. And then we're also told that AC is equal to 2x minus 6, and GC is equal to x plus 9. Alright, so that we're asked to calculate the value of x. So like I told you, this question is about proportionality, and from the get-go, the basis of proportionality, what is to be proportional? If I say something is proportional, we use a ratio, and we're going to follow that ratio throughout because it's true, but we need to first specify that this or whatever we're dealing with is proportional. So when we're dealing with triangles like this, there's a theorem that says that if there's a triangle, a big triangle, and then there is a line such that the line is from the other side of the triangle to the other side, and if that line is parallel to this one, then the whole of that triangle is proportional. I'm not talking about FD in here, I'm talking about ABC, and then we have a line FG that is from this side to that side. And if it is parallel to this, then we have proportionality. What does proportionality mean? The ratio between AF and FG, so AF and FB should be equal to the ratio of AG over GC, or the ratio of, we take this guy and we make him over this guy, AF over AB should be equal to, same thing on the other side, AG over AC. We're talking about proportion. Proportion, to be proportion, so to be sort of, to have proportionality, it means that we're not talking about units in here, but, and also we don't mean that this side AC is equal to AB. But what we're saying is that whatever you division you do here, it has to be true also on this side when we remove units and just literally look at how proportional everything is, or what happens if we divide a certain side by the other one. Then the same should hold on the other side. Okay? And then, so we already see that we are given AC there, and then we're given GC. Okay, so we should think, oh, but AC over GC should be equal to this line AC over GC. Think about it. What do we use on the side that corresponds to that? Correct. You are smart. So it is going to be AB, the long side, just like we have the long side AC here. So AB over, so GC is this side in here. Then on this side is going to be FB. We do have a ratio of AF over FB, but we don't have the ratio that speaks about AB. So how do we find it? Alright, so if we say, so if we talk about proportion here, and we say FB is equal to 5E. So we have 5 E's, literally the letters E's, and we have 5 of them. If we have 5 here, because we are governed by this proportion, it means we must have how many in AF? It means we must have 2E, so that when we divide AF by FB, we still get the same ratio. But then, if this is FB equals 5E and AF equals to 2E, then it means the whole of this line has to be 7E, the summation of these two, because these two make up the big line. So we already know that we're working with 7 in here when we talk of ratios. So AB is going to be 7. According to this ratio, if we take this 7 and you divide by FB, then you're going to cancel the E's and you're going to be left to 7 over 5. But then for AC, we have it as 2x minus 6 over, what is GC? GC is x plus 9. So how do we solve for x in here? So know that every time we're dealing with fractions, try to make things to be linear, to not have a denominator and a numerator. And how do we do that? We cross multiply. So when we cross multiply, we take this guy, we send him to this side. We're going to have 5 into 2x minus 6. We take this one, we send him to that side. 7 into x plus 9. Do you see that this is still the same thing? We can literally take this guy, divide by this guy, and then take this one, divide by him. We're going to get back to whatever we had in here. So cross multiplication doesn't say that we're making a different thing now, or we're making major changes. Still the same thing. So when you multiply in here, 5 times 2x is going to be 10x. We want to multiply the numbers, minus 5 times 6, that's going to be 30, equals to 7 times x, that's 7x. 7 times 9, that's equal to 63. So we want to solve for x, so we take all x's on the other side. on the left hand side, and then all numbers we take them to the right hand side. So this is going to be 10x. When 7x comes this side, it's going to be minus 7x. We take this negative 30, we send it to that side, it's going to be a positive 30. So we have 3x equals to 1. Okay, that's going to be 93. Then what is 93 divided by 3? So we divide by 3 both sides, and we get an x of 31. To check that this is working or this is true, you must take this x, you substitute in here, and check that we are going to get this ratio. So if you put in x 31 here, and you put in x 31 here, we're going to have 2 times 31 minus 6. This is just to make sure that your answers are right. So 2 times 31 minus 6. This is 56 in here. 31 plus 9. That's going to be 40. If you punch this to a calculator, you should get the same ratio. And yes, that's the answer. You can also check it on your side. Guys, that's all for today. Thank you very much.